introduce the chief guest to the gathering. Arul sir.
Good morning, sir.
Good morning, sir.
Good morning to one and all present here. So I'll give a brief introduction about our session speaker. He's an chairman and founder of the ABE Semiconduter Designs, Chennai. Most importantly, the combination of teacher and the industrialist. With a span of 18 years of journey, leading nearly 40 plus research teams across the nation, designed nearly 50 plus technology transfers and products, and handled nearly 200 CPU. As teacher, he has conducted nearly 200 pan-India workshops, trained nearly 5,000 engineers, and awarded as the best project guide by Renaissance Japan in 2008. As the Intel innovator in the year of 2016, designed major products such as IoT-based dementia care giving systems, single board computers, L-sticks, smart electrical appliances, hardware-based machine learning algorithms for healthcare systems, wearable devices. Now, AI creator for different technology architect. Being recipient of National Center of Excellence in Teaching, New Delhi in 2016, and awarded 100 doctorate from International Economic Universities or countries, Maldives, in the field of education and research in 2019. Now, as IoT man to machine architect, involved in the artificial intelligence research technologies which are beyond the imagination. I welcome you, sir. Now, I hand over the session to Dr. Atif Shah, sir.
Thank you, sir. Thank you, and good morning, one and all here. This is Dr. Atif Shah, Chairman and Managing Director of ABE Semiconduter Designs. To brief you about the deep learning visions for the computer vision mechanism. Actually, so here already, like we have talked, we have given a lot of things on deep learning mechanism and computer vision system. Today's session is going to be in such a manner like we are going to have some case studies from the movie and also real-time projects, which we are going to share you some of the experience what we are developing in some real-time products actually based on the vision system, computer vision system, and how it is being going to be utilized for a kind of an application. So what are the kind of an application it is going to be utilized for a mechanism? So this is what the session is going to be about. So how the modeling, how to model learning models, and how it can be fit into a kind of the computer vision system, how it can be fit into the computer vision system. So that is going to be handled today with some cases, some case studies, and something on the product oriented, how we designed it based on some applications, and some of the values what really is been taking place and how it can be done with that. So this is the thing we are going to deal with that today. Sorry. So let me start with the basics, fundamentals, and then we'll move on to the application and the most important, the designing of the real-time projects. So that is the thing which we are going to cover today, actually, right? So the practical aspects, we are going to see how it is going to be designed and what are the applications we are going to have this. Actually, like the thing we are going to start today is like when we want to know more about us, please refer to our website or surf our website abgroups.com for a kind of what we are doing. Actually, the fusion of the embedded hardwares with a kind of artificial intelligence algorithm. So you can very well surf at us, surf our website and know more about us. So indirectly, we are moving to the topic actually. So let me cover what is AIS, what is the most important whenever you develop any computer vision system. So what is the AI is all about? Let us see what is the block diagram, and then we'll see the challenges in the computer vision system in developing the models. So we need a lot of things which is happening here actually. So we will discuss what are the challenge and how for that model, how it can be, how the mechanism can be designed. So this is the logic which you are going to see here. So before moving on to the challenges, let me have, when you want to develop a vision system, not only a vision system, any AI-based vision, any AI-based system or an intelligence system. So what kind of block diagram or what kind of schema can be utilized to make it ready actually? So This is the schema which has been normally utilized for making you to understand the logic which is happening. The first and foremost thing is about is the data model. The first and foremost thing is about the preparation of the data model what we have actually. So the data model is most important, and here for the computer vision system we need to work on this different categorization of cameras. So the normal high resolution cameras what we normally use is your real-tech cameras actually, but still we have lot of cameras which is available here, and that camera will play a vital role. Preparing a data model is most important for us to make the learning model to understand what is happening. So here we need to understand clearly the vision system, the computer vision system need cameras, and more importantly it has to interface with the kind of an IoT. So that is the most important case what we have right now. It should be interfaced with the case of your IoT, Internet of Things. What is this is all about? The Internet of Things is most important. Everyone knows about it. IoT is all about your sensors, CPUs, and your transceivers. But imagine in a situation that if you connect it with the cameras, what has happened actually? So the cameras connected with the CPUs, and then whatever the GPUs what we have, and then it is to be transmitted to the cloud system, and all my video frames and the live streaming of videos will be stored in my cloud for the further processing. So we will see how these hardware plays a vital role while designing the product, how these products can play a vital role for this kind of an application. So this has to be made clear actually. First one. So IoT. So everyone knows about IoT. Now I'm replacing the IoT sensors with the cameras for the vision system. Second important application here is today's scenario. We are working on the different categorization of inputs. We are working on the different categorization of inputs. Something on fusion of something on fusion on sensors and something on cameras. So fusing the inputs, that is the fusion of different inputs into a single one. So now in a vision system, we doesn't deal only with the images and videos alone. We were dealing with a lot of sensors which are available right now. And we are going to fuse these two things. And we call this as the most important fusion or fused inputs. So this is a design challenge what we have here. Actually, we'll talk about later what is the scenario we are going to obtain here. So the logic which we have to take care about here is this. So fusion of all the concepts, the fusion of inputs, what we have to take care is most importantly most important for the input on the learning model. So this is the most two important inputs what we have to deal with that. And as we talked to previously, all these things have been stored in the DB. That is the most important. All these things are stored in the DB. So DB, that is your databases, either in a cloud or a server or with the internal devices. When you have an internal devices, there creates a lot of complexity. We will see that also. And this is the most important. And finally, when you work on the videos, everything is converted into the frames. And from the frames, we do a lot of feature extractions. So we do a lot of feature extractions, which is required actually, and that kind of feature extractions we need to adopt suitably for the learning model. And then finally we have the intelligent learning model, which is required actually. So we have an intelligent learning model that is most required for our side. In this case only we have the two categorization. One is machine and second is your deep learning model. And third is all about the decision box. So the decision box, what is all about the decision boxes? This requires a training and this requires testing and everything. But exactly what is happening, what is really happening in the real-time scenario? What we normally do is we will stop up to this. Actually, we will learn the algorithm. We will make a performance analysis of the algorithm and we'll stop here. But exactly what is going to be happen when it is going to tested in the real-time scenario? We don't do that in testing in the real-time scenario. That real-time scenario, how it works on the real-time scenario has to be followed here. So this is the logic which we have to take care about it. So get the data, collect your data and do some extraction, feature extraction, which replicates the characteristics of the data, and finally integrate with the intelligent learning, either with the machine and deep learning, and finally and test it in the real-time scenario. So we need to test it in the real-time scenario until we need to correct it for a further application. So this is the schema which is normally utilized for any kind of an application, not only for computer vision system. Any vision system, any AI system which based on cyber security, DSPs, embedded system, EVs, any electrical power systems, anything you can utilize with this kind of an application. So now we are going to face what are the challenges here. What are the real challenges we are facing today when we design a model for a computer vision system. Let me share the whiteboard here. So first thing is the design challenges. What is the design challenge when you want to develop a deep learning and your learning model for your application, the learning model for a kind of an application? The first and foremost thing what you have to come across here is the thing which we have to recognize here is the first challenge here is we need to develop a model which is resolution independent. Most important challenge what we have today in today's world. Kindly please note of this word. Actually, this is most important. Resolution independent. So resolution independent models. This is the real challenge. Whenever we do some kind of a research, we never bother about this kind of a mechanism because we'll have some standard cases and we work on the standard cases. But in industry, and then we of videos. This is the most important cases what we have. It is a live streaming of videos. So handling the live streaming of videos is most important. It is the most important logic what we have. It is a live streaming of video what we have, and what is the logic which we need to take care about it. A live streaming of video is something on the concepts what we have, and the live streaming of video is not an easy job to work with that, because the videos like we have already predefined data, predefined image, store it on it, do some training analysis. But in the case how to handle the live streaming of videos, and more important, like third important point is about handling the real traffic. As we talked about real traffics for videos, real traffics, that is most important. What we talked about is like when you want to have access your logic, when you want to access the mechanism what we have right now, we need to understand clearly that the streaming video, that is the bandwidth of your network, is important. So when you have the bandwidth of the network and the real-time traffics is most important for applying the models on the videos. So most important, because we said that it will be collected and put it up in some databases or in a cloud storage. So how to handle this real-time traffics in accordance with the bandwidth for getting a good quality video is more important. So that is more important, and how this deep learning model plays a vital role for this. This is another challenge what we have. And the fourth and final challenge what we have here is to form the hybridization, the hybrid algorithms chosen for vision system. This is another area. So because we don't work only with one single mechanism, it is to be worked with the mechanism which we have to take care about the hybrid algorithms, which is being utilized for a kind of an application. So how to formulate the new hybrid algorithm which is going to be utilized. So the logic which comes into the picture, we need to understand clearly how integrated, and this can be implemented for a kind of a logic. So we need to see how these deep learning models plays a vital role. These deep learning models plays an important role for a kind of an application, right? These are all the four important challenges as far as the input and model things are concerned, and your which we have not here regarding the hardware, the specification of the hardware which is utilized, the design challenges, the specification of the hardware which is utilized for your what you called as for the processing as well as tuning. Processing here, applying the deep learning models, and streaming is something like we need to stream it for a real-time application. So this is how the logic works on, this is how the mechanism works on cases here. The design challenges comes into this 5 categorization. It comes into the 5 different categorization. There becomes into 5 different categorization of this logic actually. So now how these models can be designed based on this challenge. This is what our motto is, how these challenges has been faced and how it can be designed with the help of a deep learning model. So this is what we are going to concentrate today. So starting from the basics, and then we'll go for the hybridization and hardware deployment, and finally different kind of research projects, how to make it out with our models and how we are making out with the vision system. This is what we are going to see. Hope you have understood what is the real challenge whenever we talk about a vision system, we normally consider, okay, the frames are coming, images, we design it. But no, that is not the case here. These are the design challenges what we have right now to work on this application. So to make it a summary, like we need to develop a resolution independent models, and second thing is we need to work on the live streaming videos. It is very complex, and real-time traffics usage, how to use your bandwidth or the real-time traffic effectively for a video transmission, and how to form a hybrid algorithms for the CV systems for handling the videos, and finally how to deploy it based on the specification of the hardware. So these are all the things which we have to take care about it. So based on this challenges, we are going to select the algorithm. You are going to see what are all the algorithms which plays an important role for a vision system. So let me have this. So hope you have understood what is the logic here. Now, so you are going to see the algorithm. So now the algorithm is going to be started actually. The algorithm which I'm going to do is like, it's my case whenever we teach about a machine learning, when we want to explore a kind of a machine learning algorithm, this is what will happen actually when you want to learn this kind of a machine learning algorithm. This is going to happen actually. So when you want to explore what is the mathematics behind it, what is the logic which is behind it, everything will create a problem over here. So in order to overcome this kind of a mechanism, we suggest you to refer this movie actually. So the movie is from Indian to, it is not a 2.2 actually, it is an Indian which was released in 2010. So this movie was released in 2010 actually, starring superstar Rajinikanth and Aishwarya Rai, where you can see lot of things which is over here. A lot of algorithms have been buried over here in this movie actually, and you can see what kind of stuff it has been handled. So the mechanism which we have to take care, about the logic is very simple actually, but still how it can be utilized and how it can be made over here. So that is being taken with the help of this movie. So what we are going to do is we are going to see the video of this movie video clipping, and purely on vision system. We are going to start from the scratch. What is the hardware and how it is deployed and how the algorithm works, and finally how to test your validation. So this is all the things which we are going to take care about the mechanism. Now I'll start my case study number 1, which I'm going to play the video. And from this video, we can able to see what is happening in the case. And we will come to a designing of a model for this vision system. Let me play the video for 2 minutes. Have a look at the 2 minutes video actually. So you will be coming across the logic, what is happening over here. So I'll play this first video for your understanding actually, right? So I'll just make this. Please watch it. It will be of 2 minutes. No, like we'll cut short the videos to 3 minutes. We'll see what is happening and then we'll derive an algorithm. So this is the thing actually. So we will have this case study actually for us, a first case study for the how the vision system works with along with the deep learning models. So let me go for the classroom session. First thing is about here is we need to understand clearly the problem what we have here. So the problem statement, what is happening here actually, so that we have to take care and we have to understand here. The problem statement is very simple actually. So identification of human robots. This is the problem what we have actually, but exact problem what is happening here, what is the exact problem what is happening over here, that we have to check it in detail, because identification of the human from the robot, that's a thing. When you see the movie clip, that is fine, it will act like as it is, that is it will have the identification of the human from the robot. But what is exactly here is that is identification of the human from similar robots. So this is the logic. So we need to identify the difference of data from the similar data. We need to identify the identification of the human from the similar group of data. It has to identify from the similar group of the data. So this is the logic which we have to take care about the mechanism. So this is the logic which we have to take care. So in this system we need to develop a model, and that model which has to differentiate the data from the group of similar data. This is the logic which we have to take care and which we have to make it out. So how to solve with the help of this machine and the deep learning model. So first I'll talk about machine, and then we'll move on to the deep learning models with the kind of an application what we have actually. The logic which comes into the picture here is, so I'll also share the code which is available for you actually for this kind of an application, right? The first thing is about, so first thing is hardware. What kind of hardware is going to be required for this actually? So the camera, so it is in this movie, there is no kind of a problem which is taking place. It is resolution independent models are not there, because everything is fixed with single cameras. So there is no kind of a problem what we have. But there is a next problem, live streaming of video. That is most important what we have to take care about it. So for this we are using a Realtek cameras interfaced with CPUs. And like all these internal storages are being utilized. All these things are being utilized with the kind of an application. So here we have to understand clearly, the CPU has the internal storage. All the training models and everything is being stored internally. It is hardware centric, not a cloud centric as we talked earlier. It is a hardware centric. So CPU, it is a hardware centric. Hardware centric mechanism. Now untake the decisions. Now this is what the hardware is. So now we have to check it out what kind of model is required. So for that we need to go for that training methodology. Methodology is something different what we have, and the training methodologies are three categorization. One is supervisory. We know already about it. So let me have this. What is all this? Supervisory, unsupervisory, and reinforcement. So supervisory, unsupervisory, and the reinforcement logic. This is the logic which we have to take care, and this is the mechanism what we have to take care about the mechanism here. So supervisory, unsupervisory, and the reinforcement. This is the logic. So supervisory and unsupervisory and reinforcement we'll talk about one by one here. So the supervisory is nothing but inputs. When the inputs and outputs are known, then it is called supervisory model. The inputs and outputs are known. Unsupervisory deals only with the inputs, and reinforcement is something different. We'll talk about later how this has been integrated in your deep learning models with the vision system. It will be complex but quite interesting. So the logic which have to be understand clearly here is supervisory model or unsupervisory model. Here it is supervisory model because we know what is the input we need to have from the robots. It's a group of robots, and it has to identify the human, the output. So it knows what is the input and what is the output. So what is the input and what is the output is being recognized, and what is the sorry, what is the input and what is the output, which is been recognized properly. So this is the logic which we have to take care about the mechanism. So this is how the logic works on. This is the mechanism. So now we are going to see about the supervisory model which has been utilized. So the supervisory model is being most importantly utilized for kind of an application. Now, how to form the supervisory model? So here we need to prepare a data model. So what is most important? So the data model is very important for us. Actually, the data model, the data model is most important. What is the data model is exactly? You would have seen in the movie, like different features are extracted. So the different features are extracted. Something on body scanning, something on sweat, right? Something on breath rate control, and something on cutting of the body, machine body, and finally the rotation of the head. So these are the things which we have to take care about the logic. These are the things which have to be take care about the logic for the mechanism. So this is the logic which we have to be taking care. So these are all the features which are extracted. So assume that it has been working. We are working manually and we are mathematically calculating when we work on the machine learning approach, because machine learning doesn't comes with the feature extraction. We need to work on the feature extraction, and then we need to put up the data, the obtained data for a kind of a logic. So this is the most important what we have right now. So assume that it has been done mathematically, and we have that for each and every frames what from the videos is constructed. So we need to understand clearly that these features are extracted manually, right? So let us assume we'll label the data. We'll make a label that is 0 for a robot. So all the things are an output value, 1 for human. 0 for robot and 1 for the human. So this is a logic which we have to take care about it. So the mechanism, what happens here is, this is the mechanism. So I'll just take here. So the mechanism here is, these are the things, and ID number 1. This is the logic. So body scanning, so what happens here is we have some thresholds for each and everything. What happens with these thresholds actually? Once this thresholds, like what happens here is the thresholds we need to understand clearly. If the body is scanned, if it shows the metal, then it is a robot. Otherwise, it is a human. So this is the thing which has been doing there. You would have seen here. So here, what I'm going to assume this: if it shows the metal, it is robot. So I'll make it 0. There is no kind of a sweat from the human, 0. No breath rate, no blood. Finally, it is possible. That is why he made its rotation of the head. So the robot can able to rotate the head for 360 degree, but human can't able to do it. So there is an output for that. That is a label. And I labeled here as 0 for the robot. So I made here as a 0. This is one kind of a data model, and you can see in the movie there are 100 data actually, 100 robots are there actually. So from the 100 robot, you can able to do the application. Now next is a human. Here for the body scanning, actually, it is one opposite. There will be a sweat and what you call this breath rate and blood and from cutting. Human like us, we can't able to rotate our head, so 0. So label what we made is 1. Now this is the data model. This is the supervisory model, the basic supervisory model, which is given for training your machine actually. So now what happens here exactly? What is the logic which is happening over here? So here, there comes the methodology. There comes the mechanism which we have to take care about the concepts. The first and foremost thing which we have to take care, and first and foremost thing which we have to understand clearly here, and ability which comes into the picture here is the most important. That is with the logic what we have and what is the basic commodities what is having here is, you can understand from the movie that each and every feature fails one by one, right? So you need a learning model which can be able to learn from only with the one single feature, because even though we have all the features as by side, but the rotation of the head is the only distinct has to understand and classify the human from the robot. So you need a powerful model which can able to differentiate the group of data from with the help of a single distinct feature, and that is known to be your support vector. So this is a logic which we have to be taking care about it, the support vector machine. Though it is older one, but it is powerful. And why I'm saying this, we will see how it is integrated in the hybridization. So the support vector machines, which is being utilized for a kind of an application, what we have actually. So the support vector machine is most important for a kind of an application which we have to take care about it. So this is the vector machine which is integrated in the machine learning as a machine learning technique in this movie to identify the difference of data from the similar data. So this is how we have to follow it. What is the model, supervisory model? Because we know what is the 100 data, feature extraction, label the data, which is what we have, and give the data. And the learning selection of model, please remember, it has to understand only with one single feature, even though all the feature fails. So that has been done with the help of one kind of mechanism that is known to be the support vector machine. That is the most important thing what we have right now. This is one kind of approach what we have. The next kind of approach what we are talking about is same supervisory model but in deep learning approach. The deep learning model, how to integrate with deep learning models. So when you consider a deep learning models, the deep learning models are nothing but an artificial neural network. They are known to be the artificial intelligence network. So this is called the artificial intelligence network actually. So the intelligence network, we know what is artificial intelligence network is. Intelligence network is something like it is similar to our brain. What we have here is like input, and then we have a brain to do the processing, and then we have output. This is the logic which we have to be taking care about the mechanism. So this is a logic which we have to take care about the mechanism what we have. So now the logic which comes into the picture, logic which we have to understand and which we have to take care about here is the input, brain, and output. So we need input layers, and we need input layers, and brain is nothing but your hidden layers. And we don't know what is happening inside the brain, so we call this hidden layers, and the output layer. This is the logic which we have to take care about it. Now, when you have the deep learning algorithm, so what is exactly which is happening over here is hidden layer input. That is when we have n number of hidden layers. Assume that if it is n number of hidden layers for a neural network, this is a kind of a hidden layers. Why? Because the deep learning needs a large number of data sets. When you want to process a huge number of data sets, my hidden layers and my training model needs deep learning. And whenever you need to process only the small volume of data which is required, then you can go for the machine learning approach. You can very well go for the machine learning approach. But when you want to design a kind of a hardware which is required, the numerous number of data, huge number of data sets has to be processed, we need to go for the deep learning. Why? Because when a student, example, when the student wants to get 50% of marks, his percentage is complete, his preparation for the examination is completely different. But when he wants to get 100% of marks, that is a full complete marks out of his examination, what he will do lot of references books, he will study a lot of books, he will write a lot of tests, makes him too thorough in his subject. So what happens, numerous number of layer training is required for him to get a good marks, actually even the 100% of marks. So that makes the difference. This example clearly pictures you when you want the high accuracy and high performances, when there is a huge number of data sets available, then you can use a deep learning model. But when the data set is less and when you want to achieve something else, you can go for the machine learning approach. So this is the most important. And for this kind of a mechanism, let us assume like for the machine learning approach, we have what you call like 100 robots in that, but in this case we are utilizing for a kind of let us assume at least 1 lakh, right? 0.1 million data sets are available right now for a kind of an application. So 0.1 million kind of an applications are available for the mechanism what we have right now. So this is the logic which we have to follow for a kind of an mechanism, and then we have to is the logic which we have to take care about the mechanism, and the logic which we have to make it out as very clear actually. So now, how to form the layer? Now we have formulated. Now, what are the input layer we have? In this case, actually, for kind of handling the video analytics and for kind of the videos and the images, and I suggest you to go for a network called CNN. Convolution neural network, everyone knows about it. And then we have GAN, adversarial network. Most important when you just make it for a kind of a satellite communication, remote sensing images. This plays an important role, neural adversarial networks. But I'm not strong with adversarial because yet to start, because we don't have the projects on adversarial, and we have been work with only with the fully of CNN models actually. So what is exactly is all about we have here, that is the mechanism we have here. So that is the logic which we have to be taking care about this. But now CNN, we are going to focus on the CNN, how this CNN model can be fit into this. Before that, we will have the layer by layer, forming of a layer by layer for the normal deep learning algorithm, how CNN plays your vital role. Normal deep learning model. The solution. So what we do here is we have inputs. The features again is given as an inputs. That is body scanning, and then sweat, and then what you call as breath rate, cutting, and the rotation. So all these features are given to your hidden layers. In the SVM, that is different, and this is different actually, right? So that it is given for the hidden layers. These features are processed because we know we are working on the supervisory layers. These features are being processed. So these features have been processed and through the hidden layers, and then the output will be between from 0 to 1. It's a logic because 0 for robot and 1 for human. So how do I identify this? How do I identify the output here after the processing? So what happens here is there comes, because the hidden layers in this input features, hidden layers and outputs should be connected with some kind of a variable, and that variable is known to be the activation variable. Similar to your the blood, or similar to the activity which is triggered in our body. So this is the logic what we have to take care about the mechanism. This is the logic which we have to take care about the mechanism. So here the body parameters, and then it is given for the hidden layers, and from the output. Output should be 0 to 1. So in order to obtain the 0 to 1, the hidden layers has to allocate some mathematical value, and that value, numerical values, are known to be the bias weights of hidden nodes. Nodes, like bias weights of the hidden nodes. This is the logic which we have to take care about the mechanism. So this is the logic which we have to be taking care about our mechanism. So the hidden layers and the bias weights of your bias weights. So bias weights has to be decided based on the output which has to be obtained here, and the output is from 0 to 1. So we need to, again, we have to check the threshold. If it is 0 to 0.5, it is a robot, and if it is greater than 0.5, it is a human. So this is how the algorithm works actually. Now, what is the drawback here is, like, I need to integrate a lot of hidden layers, and these features has to be extracted. Here, I have extracted manually about the feature and given to the hidden layers, allocated the bias weights of the hidden nodes, and find out the output, what is happening, and everything is connected, and everything is activated with the activation variable. Now, what is the problem here is, like, the feature extraction has to be done. Here, it has been done manually. But if you want to have the, as a part of our learning model, you need to go for this convolution neural network. This is most important. This is the most important what we have. This is known to be the CNN. So in general, we can say what is the logic is convolution extraction plus what we have neural network. This is the logic what we have here. This is the logic what we have here. You can see here, this is the mechanism what we have, the convolution feature extraction plus the neural network. So the convolution operation is required to perform your feature extraction, and it can do with the and trained by the neural network. Since all these layers are connected, we need to understand that it is all known to be the fully connected layer. I'll explain one by one. So first is about the input images, the frames. Then the first thing about the images is we need to filter out the noises and the background images which is required, which is unnecessary. So we need to go for the filter layers. We need to go for the filter layers, which able to, like, these filter layers or being convoluted over the input images. This is what the logic which is to be taken here. So the convoluted over the input images. So the filter layers are convoluted over the input images, or convoluted over the input images. So that is a logic which we have to take care about it. So the filter layer is most important, and the input images are most important for each and every frames. Here the frame converter is taking place here, and you have to understand clearly that this filter layer is convoluted over the input images. Convoluted. What is convoluted? So let us see some example. This is the image. Let us assume this is an image, and filter layer is something on. Right, this is the layer. So what happens here is this layer, filter layer, is being like convoluted. That is the 2, minus 2 and 2, minus 1 is being rolled over the matrix, first row and column, right? To 1, 2 and 4, 1. We'll get some value over here. And 2, 3 and 4, 7. This is another value what we have here. So this is a logic which you have to be taking. 2, 3 and 4, 7 is the another layer what we have right now. So this is a logic which is been taking place over here. And again 3, 4 and 7, 8. This is another thing, again shifted and multiplied and added. And 4, 5 and 8, 9. Again multiplied with this filter line, again a value. And then finally what happens here is the logic which has been taking place over here is, again it has to go for the next row, 4, 4 and 10, 11. 4, 7 and 11, 12. So it goes on like this, and we'll get an image over here. What happens here is we need to extract the image now, right? So the layers are integrated. The number of layers keeps on increasing until I get the required images. So that is the logic. And from the layers, I need to segment each and everything. So segmentation has to process it, and that has been done with the help of pooling layers. And all these things are considered with the pooling layers. These are known to be the pooling layers, which is required for a kind of an application. This is the most important thing. And after the segmentation and everything is done, and after that the feature maps are extracted. The feature maps are extracted. So segmentation, after that feature maps are extracted. Imagine for each and every frames. And each and every frame input images, we have to take care about the logic, which we have to take care about the mechanism which is being taking place over here. So this is the logic which we have to make it clear about the logic which has been happening over here. Now these feature maps are utilized to train your neural network. This is normally utilized. So this is normally utilized. So input images, filter layers, pooling layers, and finally neural network. So what happens here is, as we talked about, you need a lot of activation functions actually for this. And the normal activation functions we utilize in this case is RLU, or sigma model. So RLU is most importantly used as rectified units are utilized for activating everything. And since every layers are interconnected with each other, they are known to be the fully connected layers. So the number of filter layers and number of the features, pooling layers and the feature maps decides based on the what is the kind of output is required from our side. What kind of output is required from our side? So that is required, and that is being implemented, and that decides the number of layers until you get a good accuracy, until you get a good accurate mechanism. See, this process will keep on going on here, and then finally it is trained with the neural networks. So here, as we talked about, this plays an important role. The convolution feature extractor will extract the feature, whatever the things you want, and it is connected with, since it is every layer is interconnected with each other. This is fully connected layer, and it is trained by the neural network. So this is what is. In short, we can say that convolution neural network is convolution features with the training, right? So this is the model, and here the classification goes on. To have the better understandability, I'll show you another case study which you can understand here how this convolution neural network works. So here is the another one. So watch this video carefully. You can see the outputs which can be obtained over here. So the video scans itself. You can see the video is scanning over here. And then you can see here the skeletonization. This is the working style. It's been extracted here. So now you can see the skeletonization. So this is being done with the help of filtering and filter layers, right? This is done with the help of a filter layers. So you can see that the full role of a filter layers over here as an output. So you can able to make it out like you can able to understand the logic that the background images and other images have been like extracted, and that has been like solved, and that has been taken filtered out with the help of a filtering layer. So that has been done with the help of this. You can see the skeletonization, and this is being done with the help of the concept which is known to be the filter layer. And then you can see some red dots over here and the green dots. It is nothing but it represents the motors which is fixed on the human body, right? The similar thing, the motors which is fixed on the human body. Out of all the skeletonization, we need to extract the only segment, the particular joints, shoulders, and the legs and arms, because that decides your walking style actually. So that is the most important thing which has been taking place over here. So we need to check in this cases over here. We need to check that kind of an application. So here the logic which comes into the picture, is that has been done with the help of a pooling layer, the segmentation, the green and red, which represents your segmented images, and these are called as features, and these features are used to train your machine. So let me play this. Yeah, so you can see here better. Actually, you can see better from this case how it works actually. So here, this is the logic which you have to be taking over here, and you can see the best mechanism which is happening here. So the logic which comes into the picture here is this the case actually. So the red dots, it clearly explains you that has been done with the help of your pooling layers, which gives you the pictures for the joints and everything. So this is how the CNN works. So the CNN algorithm works in this manner actually. So hope you can visualize. So the role of a filter layer, what is happening, and the role of the pooling layer, which we are talking about. And finally, these feature maps are extracted, and it is being utilized for a kind of a training mechanism, and it is primarily utilized for a kind of an application. So this is how the logic works. So this is how the CNN works. Now we'll talk about this fully connected layer with a neural network, how it is going to be, how we are going to choose a model for this actually. So everything we're talking about are nothing but we are talking fully about what you call a supervisory learning model. So here, how to train this model. This comes into the picture. This comes into the picture is the next level actually, right? So what is happening here? So here, the mechanism which comes into the picture here is convolutional neural networks, convolution features with the NN training and everything will be used for the classification. Now, the logic which comes up first is how do I train my neural network? So the neural network, this is all about features, fully connected layers, but how do I train the network? And there comes a logic of convolution neural network. So let me shortcut this convolution feature, NN, called back propagation mechanism. So it has been trained with the back propagation. It should be trained with a back propagation algorithm. What is the back propagation algorithm is all about? So it is nothing but we have a group of students, and we have what is the mark to be obtained from the group of students. We know already what is to be obtained here. So the logic which comes into the picture, you have to understand clearly what is the mechanism which we are talking all about is. So something which is been related, something which is related on this kind of application is we know what is the pass percentage, and the hidden layers and the input bias, we have the assignments, we have tests and everything. So what happens if the students goes on these hidden layers, he will be giving all these tests and examinations and after that, and we have output from that. The output, we will check whether he have obtained the output or not. If he has passed with the threshold limit, if he is passed with the kind of a threshold limit, we leave it out. If he gets 60 instead of 70,
So the error is taken as a feedback to the tune your assignments. So this is what is known to be the back propagation. Very simple. That is, we have a back propagation. We'll check with the threshold. Error is calculated and error is taken as the feedback input to tune my layers. So this is how the logic works on tune my input layers. So that has been the logic which we have to take care about the mechanism. So that is the logic which we have to take care, and that is the mechanism which we need to put up with the logic actually. So this is the mechanism which we have to take care and which we have to taking care about these logic actually, convolution with the neural network and with the back propagation algorithm. So here, so this is how, but what is the complexity? We have a time complexity, since we will get a good percentage, good accuracy and everything, but still the time complexity and the system will degrade since we have taken the error as a input, feedback input to tune my bias weights. So there will be the problem. That problem is known to be the variable gradient problem. So that is the logic which we have. So this is the most important thing what we have right now in this case is actually. So to overcome this, we have another training model, convolution, neural network, forward. Feed forward network. So this is another scenario what we have. It is the feed forward network. Feed forward, as the name itself indicates, there is no kind of a feedback system which is available. There is no kind of the feedback system which is available. And from the input feedback system, in this case of the feedback system, nothing which will be happening over here. As the case of this logic which has been taking over here, there is no kind of feedback. So we have to understand clearly, it is working on single layer. It is not on a single layer. It's working on the feed forward layer where there is no feedback, but accuracy will be high. To get that kind of a logic, we are now replacing the convolution and with the concept of instead of neural network, forward network, we are using networks. That is single